Hi, how are you? How are you doing? You all right? I hope you're all right. I'm doing okay. And however you're doing, if you're not doing totally all right, I'm hoping by the end of this session, you get that feel good factor and you're like, yeah, I'm all right. I'm all right. Um, we're gonna start off. See this, and this is the context this session is in. Depending, you might be using it differently, but this context I'm building in is the beginning of the second year of A-level maths, UK A-level maths, and looking at the statistics section. And I've decided the best place to start off your second year is with probability. But to go further in probability, you need to have a good understanding of set notation. So this session, we're going to just explore and develop our understanding of set notation. Okay, and we're developing it in preparation to use set notation to solve probability problems. Okay, so that's the context there. To get started, if you don't have a book, I will recommend a book for all your notes and your practice problems that we're going to go through. Yes, there's going to be a lot of practice. It's not just me yap, but there will be a bit of that, or a lot of that, maybe. I like to talk. You know how it goes. You gotta show what you know, don't you? But you have a book, or if you're working on loose sheets of paper, make sure you have a really good filing system so you can file your pages in a good order to create a powerful tool for your revision. That's where I'm coming from there. And to start off, you want to get your date down. So whatever your date is today, put that date in there. Wow, you're not going to see that because that's where my face is, isn't it? Whoa, let's get this right. So make sure you get the date down and you get a title down, sets or set notation, and more importantly, the learning objective. That's our focus now, to be able to interpret and use set notation and terminology. And throughout this session, I'll introduce you to that language, the set notation, the terminology, and I'll try and use it as much as possible. And I want you, when you're thinking about the problems, to be using it as much as possible. Okay? Right, so we got that sorted. And also, doing this kind of work, the power of the pause. That's how I like to call it, the power of the pause. Pausing the video to do your bit is very important. So get used to that. So right now, date, title, learning objective, you pause, you get that down, then release the video to continue. So you did your pause, you have your date, title, learning objective, you're ready to go. Let's get our terminologies. Okay, so sets. We use sets to classify numbers or objects, and we use Venn diagrams. Those rectangle with some eggs or circles inside them. The Venn diagrams, we'll do a lot of work with Venn diagrams today to represent sets. So a Venn diagram is a tool to give a visual representation of sets. Now, key ideas or concepts or terminology and notation you need to be aware of. We use squiggly, and we won't call it squiggly. The name, it's a Greek letter, and hopefully I get this right. That Greek letter, squiggly. Whoa, yeah, it's a bit tricky to do, but it's pronounced. It's called XI. That's how you spell it. And as far as I can recall, and you want to double check this on Google, get a tool to pronounce it, but Xi. That's the way I believe you do it. Xi. So Greek letter Xi. That's how I'm gonna pronounce it throughout the video. If it's wrong, Xi, please forgive me. Have mercy. Put some comments about it. Have a laugh about it. But make sure you can do it right for yourself. Okay, so Xi. And Xi represents the universal set. And by universal set, we mean all the different members or elements. We'll explain that terminology of those words, but all the different numbers or objects that form part of the set, everything, the universal set, and that's represented by Xi. When we go to the work on probability, you'll see sometimes we'll use Xi, sometimes we'll use S, and S represents the sample space, and by sample space we're talking about all the different numbers or objects that we're considering to work out our probability. So there is an overlap there, but sample space, you'll understand the difference when we focus specifically on probability why that language sample space is used. But so that's xi, and you'll see how it looks in the diagram in a moment. And then we have we can call a set A, B. We always use capital letters. And then this terminology, you would we might say something like A and B, or you might have been saying A or B. And let's say a context where A is even number. That's a practical example there. And let me just I want to move these things down to make sure that you can see it. Ooh la 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 la. It's not working the way I wanted it to work, but I'll get it there. So that's sort of the ideas we're going through now, where I can say let A be the set of even numbers, let B be the set of prime numbers. Let's just write in the word prime there. B be the set of prime numbers, and that should have been a different color, but it's not working. So A even numbers, B prime numbers. Get the idea what I mean there. And then when we use the word and, A and, everything in A and set B, we use that symbol, intersection symbol. And then when we're saying A, the numbers in A or B, we use A union B. Okay, so let's say I roll a fair dice. Let's give an example. The elements in set A, or the members or elements, would be 1, 2, 3, 4, 5, 6. Those are the different numbers you can get when you roll a fair dice, and those would be, that would be xi. Okay, the universal set 1, 2, 3, 4, 5, and 6. And then if A is represents the even numbers, then what I'm saying is that set A, we would represent it, and we use curly brackets. I'm going to talk all about this in a moment, but I'm running through it now. Is the even numbers will be 2, 4, and 6. And then if B is the B is the set representing the prime numbers, then I can say B curly brackets would be 2, 3, and 5. Okay. And then when we talk about A intersection B, what we're talking about is are the members of the set that are in both set A and B. So in this case, I'm looking through that list, I'm comparing, and the number in common is 2. 2 is both an even number and a prime number. So A intersection B, if I ask you what's A intersection B in the context I'm describing, it would be the number 2. That would be the element, or the member of the set A intersection B. A union B, in terms of A union B in this particular example, well, A union B is going to be all the numbers. So I'm looking, and you don't repeat. So we have 2 in both of them. That's fine. Then we also have 3, we have 4, we have 5, and we have 6. So you can see A union B, it's all the numbers. It's either in 2 or it's either in set A or set B. It can be in both, and it's the numbers 2, 3, 4, 5, and 6. The number missing, the number in the universal set, is 1. It's not in A union B. And start thinking about Venn diagram. How would we deal with that? But hopefully that makes sense, what I'm putting together there. Don't worry, we have clearer stuff coming up, but I'm just teasing out because I think it's important to just like talk about the idea as opposed to just reading through, make a concrete example makes it more useful. So we have A intersection, it's in both. So that language, that word, both sets. A union, it's an either or, set A or set B. And then we have A, we call this A prime. A prime, the apostrophe is referred to as prime. So A prime represents the complement of A. And I'll rub that off just because I'm blocking off. So if I was to write a complement, that is A prime. Okay, A prime. Okay, that's what we mean there. So that's how we read it, A prime. And that's the complement of A. And that's the set of numbers that are in the universal set, xi, but not in A. So in this case, what's A prime going to be? If I ask you what's the set A prime, well, what we're thinking about, it's all the numbers that are in the universal set. So all the numbers from 1, 2, 3, 4, 5, 6 that are not in 2, 4, 6. In other words, it's 1, 3, and 5. And what kind of numbers are those? Exactly. It's the odd numbers, the odd numbers. So A prime, the complement of A prime, if A represents a set of even numbers, then A prime is going to represent a set of odd numbers. So that's a complement. That idea we've addressed there, complement. Not in A, but in the universal set. And then A, this symbol is a subset symbol. A is a subset of B. A is a subset of B, and that means every element in A is also in B. Every element in A is also in B. In this particular case, we don't have that situation. But if I was to say, let's see, if I was to just add, I don't have a lot of space to add it here, but if I was to say C is the set of numbers, if I was to say C is the set of numbers that are multiples of 5, then in this context with the universal set 1, 2, 3, 4, 5, 6, then C would have to be, the only number that's a multiple of 5 is 5 in that list. And then now we have a situation where I can say that C, which only has the element 5, is a subset of B, because 5 is all the elements of C. The 5 is an element of B. So C is a subset of B. That's the idea of the subset, the subset concept. And then the empty set, that's the symbol for the empty set, a circle with a line through it. That's a set with no numbers, no objects. It's empty, has nothing, no members, no elements. Okay, that's the idea there. In this case, if I was to say D, if I gave a set D and I said this set D represents numbers greater than 6, then in the context of rolling a dice, that's an empty set because there are no numbers greater than 6. That's the idea of the empty set. So those are the initial big ideas we need to work with, and hopefully that makes some sense. You can do your scribbles. Remember, I'm pressed for space on the board, so I've got to wiggle around to make sure it's clear for you to see, but also that I can get a couple notes in to add to what's on the presentation. Hopefully I've achieved that, and we're going to move on. Now we're going to use these ideas in context. So some of this I indicated already. We have a new example, and you can see it's using the numbers. It's saying xi, the universal set, has the numbers 1, 2, 3, 4, 5, 6. But we're saying it that so we can think about it. The dice is rolled, but this time set A, the elements of set A are 1, 2, 3, 4. The elements of set B 4 and 5. So not even numbers or odd numbers. We've just arbitrarily made it. Look at this really important idea. I didn't mention it, but it's critical for our work in probability. The idea that the curly brackets, so you can see we're representing all the members of the set. It's curly brackets, commas between the numbers, between the members of the set. They're numbers in this case. And the curly bracket designates, it represents a list of equal choices. Each number in that list has an equal chance of being selected. And you know, being equally likely is important for our probability calculations. So that's what it represents. And some of this, you've been hearing me using this language about elements. Another word for element is a member. The objects or the numbers that form the set are called the elements or the numbers. And the elements are written inside a pair of curly brackets, as we've seen here. The set always in a capital letter. So we want to stick with that. Okay. Now that we've talked about that, well, there's a couple questions here to do. It says example 1, but me do an example? No. This is the moment where you've already seen me do some listing of sets. So just going back so you can see how I wrote A, curly brackets, all the members of A. In this context, A was the even numbers. And we talked about what A intersection B, it would be 2 in this case. A union B, 2, 3, 4, 5, 6. In this new context, I would like you to write down what the members of every set. But to help, and you might think you don't have to do it in this simple example, but I want you to get used to it. So the first thing I would say is, I would recommend, and I want you to do this, is can you draw a Venn diagram? Can you please draw a Venn diagram to represent xi, the universal set, and the sets A and B, which are in the universal set. So can you draw a Venn diagram to represent that? And you have the power of the pause now. You need to pause and go through it to just help with that, to move that on a little bit. I'm just going to pop just a reminder of what that structure of the Venn diagram would look like. So you have that there, and you pause, you have to go build a Venn diagram. Okay, so this is what your Venn diagram should look like. We'll label Xi on the outside. And the elements of A was 1, 2, 3, 4, but looking at B, the set B, you can see that that element, that member 4, it's in both of them. So 4 has to go in the overlap of the two. Well, I always say circles, but they're eggs. They aren't circles, are they? So 4 goes in the overlap section, and then we have the 1, 2, 3. So you can see if the whole circle for A is 1, 2, 3, 4, those are the elements of A. But the 4 is also an element of B. When we look at the whole egg for B, we have the 4 and the 5. Now that we have that Venn diagram, you can see how that looks in 6. 6 is not in A, it's not in B, it wasn't in the list of either of them, it wasn't in the list of elements, so 6 is outside of the eggs, but it is in the universal set. And you'll be familiar with this sort of setup, the Venn diagram setup. You perhaps are familiar. I'm working on the premise that you are familiar with that. Okay. So now what we want to do is we want to actually, well, write down using set notation. Let's go from the visual to the symbolic. And I can write the set A. This is what you need to do. This is what you were asked to do. So if you haven't done it as yet, this is what I'm expecting for A. You would write A intersection B, and you write, well, what are the members of this set? What are the members of A intersection B using curly brackets? For B, you're doing the same thing for A union B. What are the members of that set? What are the elements of that set using curly brackets? For C, A complement. And then for D, oh, I could get D to fit there. B complement. Okay, and actually I'll write in D after, but you understand what I'm asking. So if it wasn't clear before, can you write down, using your curly brackets, write down the members, define each of these sets? Okay, so that's what you're doing. You have the power to pause. You pause and do that if you haven't done that. You have your Venn diagram, which makes it easier to do that. I hope you'd agree. And you also see there's another reason why we need to be able to understand and move between visual Venn diagram and symbolic set notation. That is very, very important going forward. So now doing it. A intersection B. A intersection B, remember that intersection, we can think about it in terms of the English language as the word and. So which elements, what element is in A and B? And where is that represented in the Venn diagram? Well, that is the intersection, the overlap between the two eggs. So the element in that overlap section is 4. So A intersection B, 4 is the only member of that set. A union B, well, how do you represent that in the Venn diagram? What does that look like? Well, that will be, and I'm going to rub off the intersection bit. I'm going to write A union B. Well, that is all the members in A, which is the whole of the first circle, the A egg, and it also means all. And I'll do it. You can see I'm doubling up. That's an important idea. You'll see when we get into more advanced work. How do we deal with that doubling up? Comes when we work in the symbolic world. But all the elements in B, and probably I should have put that in a different color just to make, bring home that idea that 4, well, we can't, oh my goodness, we can't see the 4 anymore because of that. That's what I thought would have happened, So, right, we're just going to stick, but it's cutting into the 4 in the middle. So that's A union B, that the combination of the two circles. And we would put that in the elements. If I list all the elements of A union B, it would be 1, 2, 3, 4, and 5. No, we don't write the 4 two times. We don't write the doubling up. Although there are 4, and look what's happening here. There are 4 elements in set A. There are 2 elements in set B. 4 and 2 is 6. But actually, when we combine them, it's not 6 elements. There's actually 5. It's actually the number of elements in set A union B, and we represent that. I'm just skipping ahead here actually, but if I ask you how many elements, what's the number of elements in a set, we'll put an N in front of A union B So you can see n, that means number of elements in A union B, and that would be 6. So we're not listing the elements, we're just saying, well, sorry, that would be 5. We're not listing the elements, we're saying how many elements are in the set, how many elements are in the list, and it's 5. And how much is it? It's actually what you're seeing there, it's the, I was going to go into probability. You see, this is what happens. You know, you just start bringing it up. You know, it's all the number of elements in set A, and we added the number of elements in set B. That's the four elements here. That's NA. NA is 4. NB is 2. 4 and 2 is 6. But then we had to take away the number of elements in what set? We had to take away the number of elements in the set A intersection B, the overlap. Take away the number of elements in A intersection B. That's an important formula. That's an important formula. We're going to actually deal with it formally later on, but it just fit into what the discussion here, and I thought I'll throw that out. When it comes to counting the frequency, the number of elements in sets, which is very important, you know, counting frequencies, the number of is very important in probability. Then when we're thinking about the union, we deal with the overlap by taking away the intersection. Okay, so that notation is important. Make a note of that. We're going to deal with it formally later on, but make a note of that. Make a note of that. Let's do C. And also the use of the n. Make a note of that as well. Now A prime. I say A complement. That's a bad habit, and forgive me if I do that. Expert mathematician that happens to be looking at this, please, please, please have mercy on me. When I say A complement, it's the complement of A, but A prime, you know, A prime, that's what the apostrophe indicates in maths, because we use it for calculus as well, where you'll have F prime is another way of representing. So if I have fx as my function, then the differential, the first differential of the function will be f of f prime x. You should be familiar with that notation in calculus. Okay, not going to go there any further, but that you should be, that's, so we say f prime, and then the second derivative would be f double prime, and so on and so forth. Let's finish. We had A prime, and A prime would be all the elements that are not in A, the complement of A. So we're thinking about everything outside. Now we're thinking about everything that is outside of this circle, and the numbers, the members of the universal set outside that circle are 5 and 6. So A prime would be, that's supposed to be curly brackets, not the pound sign, 5 and 6. And then for D, I'll finish this one here. I'll write it here. For B complement, it's all the elements that are not in B, so not the 4 and the 5. So B complement, you would represent as 1, 2, 3, and 6. That's B complement. Happy with that. We have one outstanding question to answer. The matter of, is B a subset of A? Now, do you remember what a subset is in the discussion we had previously? What's a subset, and is B a subset of A? The answer is no. The answer to the question is no. But why is the answer no? I'm saying B is not a subset of A. Why? Exactly, because you have it in your notes, because you've been making notes from the video. Those key ideas, it's just key points. I'm not going to give you the world of stuff, just key points. All the elements of B are not elements of A. So I can write no, 5 is not an element, or I could have said a member element of A. That's a proper answer. So because all the elements of B are not elements of A, B is not a subset of A. Okay, right, so that's it. You'll notice to do this question, we had to rely on identifying the regions of the Venn diagram. And identifying regions in a Venn diagram is super, super important. It will help you immensely. So let's practice that. We know these two regions. We know the intersection, and I have that visual there clear. If you have two sets of any numbers of objects, then the intersection is the overlap between the two eggs for A and B. Similarly, the union, and we've dealt with this already, the union is the combination of the two, and we do have the overlap in that union. We've talked about that overlap. We quickly looked at how we address that overlap in counting. And I'm mentioning it now because of how important that is. So just be mindful of that. It's going to be critical in a lot of work we do for probability, managing or our understanding of that overlap. The intersection is the overlap. That's really important. Let's quickly remind ourselves of notation, and we just looked at visualizing the intersection. We looked at visualizing the union between two sets. I'm saying two sets because we're going to scale. We have to scale this idea up to 3. We have to be able to scale it up to 3 sets. The other one is I just want to remind you one more time, because we're going to have to use it as we go forward, about the complement of A prime, and using that notation to represent regions in the Venn diagram that do not belong to the set. So A prime to complement the set of elements that do not belong to the set, or in a Venn diagram, the region of the Venn diagram that does not belong to the set A. That's really important. And then the idea of subset, again, just reminding you of the idea of subsets. For A to be a subset of B, then all the elements, the entire region in the Venn diagram that you would shade for A would have to be in B. That would indicate that it's a subset. Okay. Now let's start using this idea in practice, visualization. So this is the second bit we want to deal with now. Identifying regions, shading regions, shaded regions, identifying them. So I'll ask you now to pause, and based on everything we've discussed so far, if you can use set notation to describe the shaded regions in A and with B. Look at that one with B with 3. How would he do it with 3 sets? Okay, so have a go at that. Obviously, I'm going to do it next, but please have a go. You want to get stuck in and then compare your ideas with my ideas. Refine your ideas maybe, or do a dance. Oh yeah, is what might happen if you got it for yourself. That's really important. Okay, so off you go on that. Pause. Use the power to pause. You do it. Right. Great. Now it's now it's my turn. So let's see the thinking through this. I have a situation where what's shaded is not in A, but it's in B. That's the way I'll describe it. Look at what I've done there. I'm talking about it in English, not not using set notation, but just using standard English. Not in A, but in B. Or another way I can say it is only in B. That's what I'm thinking about. Only in B. How do I represent that? Well, if I put not in A, and it was more useful for me to write that down, not in A, then I'm thinking about the complement of A. All the elements that are not in A, it's the complement of A, using the symbolism of A prime. And then, well, hang on. This is a bit you got to think about. Well, if I just have A prime, now we got to think about what set we're going to intersect it with, or union, join it up with. That's what we're thinking about. How do we use the intersection or union concept? Because if I just think about A prime and I ask you to shade the region A prime, then what I would expect you to shade actually is all the stuff out here as well. Everything, all that. That would be, now I have A prime shaded. Let me make a small one up here. Small. And what I'm saying is that A prime is everything that's not in A. That's what A prime is. But look at what do we have here. We have A prime, but we've cut out, we haven't shaded the region that's not in B. So we now have to dealt with this idea of not in A. We've dealt with the A prime idea, but what we haven't done is dealt with the but in B. So it has to be in B. Has to be in B. I put but really the better word was saying, is it or and? Because if we use the word and, then we're thinking about the intersection symbol. If we use the word or, we're thinking about the union symbol. You can see the interplay with the words if that wasn't something you were thinking about at the moment. And what we're saying is it's not in A prime, not in A, so A prime, the complement of A, but it has to be in B. So what we want is intersection and it is in B. It's not in A and it is in B. Is the you know, it sounds better to me saying but in B, but this is what we're looking for. A prime intersection B. That is the region that is shaded. The A prime, I showed that at the top, but then we're cutting out the bit around because we only the bit that's not in either A or B has to be cut out. Because we only want what's in B. So it has to be and it is in B. It's not in A and it is in B. A complement intersection B. What about this one? What about this one? And you have a chance, if you didn't do this before, but what I've just described here, you have a chance to try and apply that idea to B because they are similar. Use the power to pause and you have that go. I'm going to do it now. Now, for this one, what I'm going to think about is, okay, right, in A, I'm going to write in A. So definitely have A. Not in C. I'm going to put not in C because everything that's in C has been removed. And if I'm writing not in C, look at what, in A, if it's going to be in A, I'm going to have to use the letter A. If it's not in C, none of C is included, I have to use C prime. And then none of B is included, so I'm thinking about B prime. That's my initial thinking. Note what I said there, initial thinking, because you're going to see that it's I'm going to change. Well, you'll see how things are going to change a bit. Not in B. So are we happy? That's the situation there. It's not in B. It's not in C. It is in A. So that's currently my thinking. And I could come up with notation for this, but then I look at it again and I thought to think, well, hang on. Wait a minute. You know, and I look and watch this. Watch this. Have you seen this? Have you seen this? Okay. You know, and this is what makes these things. Oh, damn right. I gotta keep that space for my head. You gotta see me, yeah. Well, that's the best part of the video, isn't it? I'm just being silly. Right. Okay. The look at this. Well, what's that? If I shaded those two circles, what am I shading? It's not shaded down here, but that's what am I shading? When I have those two circles, what do I shade? Those two eggs. Well, those two combined, these two combined, that is B union C. It's B union C. So that's B1. I'll call that B1. And then if I look at this situation, let's look at a second situation here. So we got the B union C, and then if I was to now write if I was to now shade, and I'll just put the three of them really small there. I'm not doing this any justice, am I? Oh man, space is a problem. Right, okay. I'm gonna scroll down. I gotta scroll down because I don't have enough space, do I? So look at what I'm showing you here. Look at what's happening here. Okay. Yeah, that's good. That's good. Look at what's happening here. If I have the three circles, yeah, we got the three circles there. But I was to now shade, so we know that these two, shading these two, that will be B union C. But that means that if I shade everything that's outside of it, everything, note what I'm saying, everything outside of it, well, what am I shading now? What's the shaded region now? I've shaded everything outside of the B union C, and if it's not in B union C, note what I said there, not in B union C. And actually, well, think about it. If it's not in C and it's not in B, what we're actually saying is that it's not in B union C. And if it's not in B union C, how do I represent that? That is B union C complement. We put it in brackets, B union C. The whole of the B union C, we want the B union C prime. Sorry, I told you I'd make this mistake of saying. So B union prime is the entire region that we're seeing shaded here and all the other bits going around. So that B union C also includes all the bit I'm shading in green. Everything all the way around except the unshaded region. That's B union C. That the shaded part we got, and on the extra I've added on. Now, when I said extra, I added on. But so I've dealt with this not by having to write C prime and B prime. We could just put B union C and B union C prime. You with me on that? That is the outside region, and then but we didn't want the extra bits. We're now restricting the B union prime. It is B union C prime, but then it has to be an A. And how do I add that additional condition that it has to be an A to do that, to achieve that? Look at what we did for the first one. We said intersection B, A prime intersection B. This time it's B union C prime, because two circles combined are being left out, but it has to be an A. So what would we write as our final answer? It's B union C prime intersection A. How do you feel about that? B union prime intersection A. That's what we're doing there. That's what it is. That's what it is. All right. Okay. But now that looks and a pretty yeah. But you oh God. Let's tidy up. We've done a lot of working. What I've tried to do there is to go through to make my thinking visible, the process that and try to replicate what might be happening in your mind. You start thinking about something one way, and then you have to go through a process of refining your thinking, and that's what I've tried to replicate. And hopefully, this is a useful technique that helps you to understand the concept. What I'll do now, let's just write it. There's one more point I want to bring across on this before we go the other way, where we look at not naming identifying the name of the shaded region, but where we're given the complex, I'll call it a complex set notation expression. We have to identify, so we have to shade the region. So doing the opposite, we'll do that after. But just quickly, let me just rewrite these in a clean screen, so you can see that we went through the process of identifying this as A intersection A prime intersection B. And what I wanted to mention is that order does not matter. Order does not matter. So I could have written the answer here as B intersection A prime. And yeah, so you can do either one. Similarly here for B, where I wrote it just now as B union C. That's the two combined, B union C. But we want everything that's not in B union C, so B union C prime, B union C prime, but then we're not including every part of B union C prime. We want the section that intersects with A. In other words, we're saying everything that is only in everything that's in A, but not B or C. That's another way of thinking about this. And similarly, we could have written this putting the A first. We can put the A first, A intersection B union C prime. Okay, the order, we could have swapped the order. I just wanted to get that across that point, and also to make sure the expressions were clear on the diagram, because the thinking is messy. And what I just did there is a bit messy, but remember, you can go over it, and hopefully, I think with the color coding, I used a lot of green, but yeah, I think you'll get that point there. Okay, right now, uh, let's go the other way, and then I will let you loose to practice questions. You know, we've gone through some big ideas. Let's just go the other way. Um, Here's a situation where I have given you, or not, I haven't, but the question provides you with the set notation. It's A union B intersection C prime, and you need to shade that region. So pause, have a go, shade that region. What do you come up with when you shade that region? And I'll provide you with a hint. Let's say if we're unsure where to go, I'll provide you with a hint. You want the union of A and B, the union of A and B, which is not in C. So we started using that idea. C prime is not in C, but it has to be in so everything that is in A union A and B, but not in C. That's the region you're looking for. And let's look at it. Let's look at it. I'm gonna do the, okay. Yeah, you had the power to pause, and you should have your solution now. Okay, you have the power to pause, you should have your solution. Look at thought process going here. Okay, first bit, I have to have A union B, not in C. A union B, it has to be an A union B, but not in C. That's what we want. So I'll shade A union B. That's the first bit. But look, I'll do it slightly different here. A union B in this diagram is actually 1, 2, 3, 4. I'm running out of colors, but we could keep 5, and then 6. That's A union B. A union B in a diagram like this with 3 sets, A union B is made up of 1, 2, 3, 4, 5, 6 different sections. That's A union B because of the overlap, there's parts of A in C, there's parts of B in C. So but then what we're saying here is we want all of A union B, so we want these 6 sections except the sections that are in C, because the criteria, the additional criteria is and not in C. So and not in C. So what I need to do? I need to remove the sections of A union B that are in C. So and I think, yeah, this is a moment. If it was, yeah, this has to go. It's in C, so it can't be part of what we have identified what we want. But and then we're taking out all the extra, all the excess. Anything in C we want not in C, so anything in C has to be removed. That's the area you should have shaded. Obviously, you need to shade it really, 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 really nice. Yeah, you want to shade the whole region, but you get the idea. And the reality is that, from an exam perspective, I won't expect you to have to shade, or that's sufficient. But it's about what we're doing this because you need to identify the regions from a probability perspective. You want to identify the regions that you're going to include in your counting to work out probabilities. That's what we're doing this for you, to help you to develop your ability to identify regions that you would include in your counting to work out your probabilities. That's why you need this skill, why it's so important. Okay, so that's the representation of A union B intersection C complement. And at this stage, I want to think we've gone through enough, and I've explained the thinking processes sufficiently that I'm going to let you loose on some problems. The first one up for you to do, question number 1. Here's a Venn diagram. All the members of each of the sets are presented there, and what you want to do is to indicate what are the members of all the sets mentioned below, the combinations of sets mentioned below. So, and just to make it clear, a reminder, we did these. This was based on the first example, but let's say I want this is A intersection B prime, by the way, to just make that clear. And I'll just do the first one. If we want the set, so A intersection B, what are the elements that are in A intersection B? We'll use our curly brackets. And A intersection B, that's the overlap between A and B. It's only one member element. 21 is the only member of that set. A intersection B, because again, if I shade, this is the region A intersection B. And what we have here is a list of elements. So you're listing elements using curly brackets. So that's what you're doing for the rest of this exercise. Off you go. Pause and you finish the rest of this exercise. And now it is answer time. So here are the answers to question number 1. You have these. Go through these, mark your work, make corrections as necessary. And make sure you're satisfied. Make sure you can spot your mistakes and realize, okay, yeah, that's why I got it wrong. And if necessary, add a note to that can help with revision in future, something to guard against when you're working in future maybe. Let's go to so you have the power of the pause. I love that power of the pause. You're in control of me. You are in control of me. Enjoy it while it lasts. Okay. Yeah, pause, finish marking your work, and I'm gonna move on to the next question. So this is the next one here. Now I've given you some regions. I want you to use set notation to describe each of the shaded regions. So you're using set notation to describe each of the shaded regions. Pause, and you have a go at that one. Good. Brilliant. Here's the answers. Whoa. That's what we wanted. Here are the answers, the 3 answers. I've put them in there. So pause and mark your work, and hopefully satisfy yourself that those answers are okay. Hopefully it's what you have. That's brilliant. What I want to focus on now, is F, and you'll see. I'll scroll down. Remember, you should have paused and you go through it in your own time, at a pace right for you. I want to scroll down to F, and you would see that I have a new diagram here, and the reason for that is, well, what I wanted to talk about now is a different way to write F. To represent F using set notation. We have, and do you have a different way? And you're thinking now, oh, I got it wrong. Well, maybe you didn't get it wrong, because there's another way to represent this, and I want to go through that process. So we know, I think this is the answer I would expect most people to come up with. It's how my brain would work, because I'm thinking the 2 circles and a bit in the middle. It's not shaded, so I know the word not is going to come in. But what's the name of that region? That region is K intersection L. So as soon as I look at this, what I see is not K intersection L, which is what we've put K intersection L prime. That's set notation for not K intersection L, not K and L together. Nothing that's in K and L together. But let's think about it differently. And you need this not because, remember, you don't have in an exam, they could represent a region using a different notation. And if you can't transfer the way they represent it into interpreting which parts they're talking about, you're going to run into a problem. So you need to be familiar with all the different ways to represent the regions in a Venn diagram. So let's just think, well, if I ask you, and on a diagram, do this, go through the process. Shade K prime, the complement of K, all the element, region that represents all the elements not in K. Draw a diagram, shade that. You've done it. Okay, good stuff. What did you shade? You should have shaded. This is what, so let me label it. I have K, I have L, and what you should have shaded was this bit here. K complement is all of this. Everything that is not K prime, sorry, I told you I did this. That was my disclaimer to stop. K complement, the formal, that symbol apostrophe means prime. So K prime, which means the complement of K. That's what I've shaded there. Happy with that? All the elements that are, all the elements, all the regions in the Venn diagram that are not in K. That's what I've dealt with there. Yep. Now do me a favor and shade L prime. Shade L prime for me, please. Pause and you do it. Yeah, you got it. Well, what you should have now is, well, L prime is everything that's not in the circle L, not in the egg for L, or not in the set L. And well, hang on, that's all of this going around. Want all of that as well. Yeah. And well, look what's happened. What has not, where have we not shaded? The middle. We haven't shaded the intersection. So actually the other way of saying K intersection L prime is actually saying K prime, was it going to be union or intersection? It's the union. It's everything in K prime or in L prime. It's the union of the two. And let me just shade this bit in to make that clearer. Okay, right now, the union of the complements of each set. And you might be thinking, well, hang on, it was intersection. It was intersection when we had the bracket, because I'm trying to get you on a big pattern, to spot a big pattern here. It's the intersection on the first inside the bracket, but if I take out the brackets, if I remove the brackets, it's sort of like expanding brackets. That's one way of thinking about it. We have the K. I've got to use that carefully, but I'm just trying to help you spot a pattern. We're using K prime, the complement of K. So we have K prime, we have L prime, but we have to use the union symbol. And you might say, well, why am I not using the intersection symbol? Look at this. Look at this. Let's look at what would happen if we went with the intersection symbol. If I ask you, shade, okay, you do this now. Shade K prime. Shade K prime. And what we want to do, now we're representing, we're shading K, actually, so don't take back what I was going to say there. K prime, don't shade it. Stop. There. Yeah, so, my bad. Okay, K prime, let's look at what K prime intersection L prime would be. This means, remember, intersection means add, and why I asked you to shade, not to shade it, is because you're going to have to rub off. But the way I would do it, look at what I'm going to do here digitally, is K prime. Well, K prime has this region, everything on the outside. K prime also has this region. A bit of K prime, not in K, is in L. Similarly, L prime, all of this is L prime. All outside the two eggs is L prime. I'm putting it in yellow this time. Also, L prime includes this region, the bit that's in K but not in L. L prime, remember, L complement of L is everything that's not in the egg that represents L. And look at this. If I tell you K prime intersection L prime, it has, and so intersection means and, it has to be in both K prime and L prime, then what has to happen? What has to happen is that the bit of L prime that's in K has to go. The bit of the bit of K prime that's in L, that region has to go. That's what we're left with. You can see it's a different pitch here. K intersect, and what picture is this? There's another way you were going to name this, and hopefully this brings home the relationship between these brackets. Let's just get this on screen. It's tight. Things are tight on the screen. But what I'm trying to get to is that the other way of writing K prime intersection L prime, and it's really, really clear here, I hope. What region is not shaded? These two, I have the two circles, the two eggs combined. It is K union L. See, we've switched the sign, K union L. And, well, what I've shaded, the shaded region, is everything that's not in K union L. So, in other words, K union L complement is the same thing as prime is the same thing as K prime intersection L prime. If we take out the brackets, we flip the symbol. Intersection becomes, union becomes intersection. Look at those relationships there. K intersection L prime, so everything that's not in the intersection is K complement union L complement. And inversely, K complement intersection L complement is K union L complement. Hopefully, you might have to look at that again, but that's a big, hopefully, aha moment. Oh yeah, I'm getting this. And you're going to have to use, you don't know in an exam the way they would represent the problem, but you want to be able to use this logical thinking to deduce what region is they're referring to, what parts of your Venn diagram you need to include in your counting for probability. Let's move on. I love this logical thinking. Brilliant. That's what this is about. It's about logic and logical thinking. Venn diagram, a tool to aid your logical thinking. Question 3 for you to look at, P3. here's your test. You got to draw 3 separate Venn diagrams, and in each Venn diagram you want to represent the region. You want to shade the region represented by the set notation provided. So 3 of them. Off you go. Power the pause. Pause. You're working on these, please. Thank you. Nice, nice. This is what it looks like. These are the solutions, and hopefully they are what you have, and you can do the dance, Oh yeah, if it's not, then study the diagrams carefully and try to go through those visual thinking, those thinking processes that I described. I tried to be visual and be in the earlier parts of the video to make sense of it. If it's still not making sense, of course, just get me in touch, pop a message, and I can look at that. I can explore that for you. Now, last one more set of questions to do. Logical thinking, gotta develop it. So important. Here you go. Here are 5 Venn diagrams, and now you're identifying regions, but with 3 sets. Can you please pause and write down the set notation that represents each of these? Write down the set notation that represents each of these. Look, look at B. We haven't talked about this. This is an important concept we're going to discuss at some point, because look at what's happening. You can have a Venn diagram where the circles don't overlap at all. Or you could have, look at C, a situation where the circles only overlap. They don't. So for example, A and B have an overlap. So there's A intersection B, there's a B intersection C, but there's no intersection, A intersection C does not exist. So there's lots of different strategies you can use to represent the information provided. It's not always 3 overlapping eggs that are used to represent sets. It's very important that we're aware of that. Okay, in the pause, you use the power of the pause. You're identifying these. Okay, and in your books, hopefully you've been doing it, do a quick sketch and then you're putting it down, because you want your book to be the thing you can hold. You have your book with you and quickly go through it as revision notes, because you obviously would have added the key parts of this video that are relevant to your understanding. Everybody's different, so how you'll structure your notes would be different to personalize this. And yeah, power of the pause, you've gone through these. Here are the answers, here are the answers, these are the answers here, okay? Did you expect that for B? Did he have that? There's no overlap, but it is all of, it's either, remember, intersection means or. So, union, sorry, means or. So A or B or C. That's it. All the elements that are in A or B or C. It doesn't matter if there's overlap or not. Okay, A or B or C. Look at what's happening here. It's that's the starting point of these. You read it, you think about it in English terms, and then try to convert that to set notation. Your starting point is it has to be, the elements have to be in B. That's clear. And then you start thinking about pieces have been taken out of B. What are the pieces? And then you have intersection of A complement and intersection of C complement, because what you've taken out, what you do not want, in other words, what's the additional criteria, is not just it has to be in B, it must not be in A. I want everything that's in B and not in A and not in C. So that those 2 extra bits on the left, at the top left, bottom right, we take them out. It's in B and not in A, so strip out that piece, and not in, see my hands are not in, doesn't make any sense. See my, not in A, strip out that piece. Not in C, strip out that piece. That's in C. That's the logic we've built up there. Okay, right. Hopefully we're okay. Questions, just pop messages. We can have discussions as appropriate. That's it for set notation. For that, yeah, that we're in a good place with set notation. Once you've got yourself on this, yeah, you're good position.